Hey, Algebra 1, this is Chapter 3, Section 9. This will be the third video on mixture problems. I think I'll do four ones, so there'll be one more after this. So this is the third of 4 in the series. So we've got an alloy or metals is 25% copper. Alloy means a mix. Another alloy is 50% copper. And we mix our metals because copper is a really soft metal, and if you had pure copper and you used it for a bracelet, it would lose its shape and get all banged up and everything. So you mix it with a harder metal so that it keeps its shape better. So we want to know how much of each alloy should be used to make 1,000 grams of an alloy that is 45% copper. So let's look at this and see. We've got 25% copper, 50% copper, and 45% copper. So that's what I'm going to put down my side. 50% and 45%. Okay, then you want to know how much of the alloy we have, how much of the mix. So this is going to be pounds of the alloy. Alloy just means a mix of your metals. So an alloy or metal is 25% copper, another is 50% copper. How much of each alloy should be used to make 1,000 grams that's 45? So we know that this is 1,000 right down here, and this is in grams. So let's put my little G up there. Okay. Then our last column is going to be how much copper. So this is going to be pounds. Actually, this isn't pounds at all, is it? This is grams. So let me fix that. Erase that all off there. That was being very silly of me. So this is grams. Grams of this alloy, and this is grams of copper. Okay, so we've got a bunch of stuff, and none of it's filled in, so we've got to start filling stuff in. We want to know how much of each alloy should be used to make 1,000 grams. Right? That's our question being asked. You should always start all problems with trying to figure out what really do you need to know. Well, we know that in total we have 1,000, which means that this number here needs to be added to some number and get to 1,000. So if you've got x plus some number, you have to be 1,000. Well, how do we get to that one number? We've got to get it by itself. So to get it by itself, we've got to subtract this x from both sides. And you end up with this actually saying whatever that is equal to 1,000 minus x. So I'm going to put 1,000 minus x, 1,000, another 0 there, into my little box. And it does in fact work. If I could take x plus 1,000 minus x, the x's would cancel and I would end up with 1,000. So let's get rid of this work down here so I've got room for the real problem here. So that was my little side note to figure out how to fill in those. So that's my trick. X and 1000x gives you 1000 when you add them up. Okay, so when you're adding, that would be equal to that bottom one. Now we've got grams of copper. Well, if it's 25% of this stuff, of that stuff, is our grams of copper, then of means multiply. So 25% times x is going to be giving equal to this. And we don't write 25%, we write that as 0.25 when we're doing math. So it's 0.25x. Same thing here, 50% of our grams of 50% alloy is going to be equal to. So this is an of here, and this is equals. And of means multiply, so this is going to be 0.5 times our 1,000 minus x. And then we have the same problem we've had in the last problems is, well, how do we fill in this corner box? Well, you can either come down the column or across the row. So 45% of 1,000 is going to be equal to that number. Or I'm going to have so many grams of copper plus so many more grams of copper to be equal to our total grams of copper. So I can write that as 0.45 times 1,000 is going to be equal to, and then come down, that's going to be 0.25x plus 0.5 times 1,000 minus x. And now we have our equation with one unknown, our x variable. So we need to solve our equation. We've got a distributive property to do first. So I'm going to distribute my 0.5. And I'm probably going to multiply this side also because that has no effect on my end and I don't need to do it in 2 steps. So 0.45 times 1,000, when you're multiplying by 1,000, there's 1, 2, 3 zeros. So we're going to move our decimal 3 places. 1, 2, and 1 more. So that makes that number 450, and shame on you if you grabbed your calculator for that. Then I'm going to rewrite my 0.25x, and then I'm going to distribute my 0.5. That's a decimal point. So 0.5 times 1,000, again, I've got 1, 2, 3 zeros there, so I'm going to move my decimal 3 places. So 1, 2, 3. That's going to be a 500 minus 0.5x when I distribute my 0.5. Then I can collect my like terms. And this is where I think fractions, and I don't think in decimals, but you can think decimals if you want. So I think of this as 1/4, and I think of this one over here as 1/2. And I know if I have a half and I take off 1/4 of it, I'm left with 1/4. Or you can think of this as money. So this is 50 cents minus 25 cents gives you 25 cents. So this would be a negative 0.25x plus 500. Why is it negative? Well, the 0.5 is bigger than the 0.25, and it's got the negative sign on it. So the final result has to be negative. And then I bring down my 450. Now I want to get x by itself, so I've got to get rid of the stuff with the x, and we get rid of addition and subtraction first. So I am going to subtract 500 from both sides. And that gives me a negative 50 on this side is equal to a negative 0.25x. And again, I don't think of things as decimals. I always think of them as fractions, and 0.25 is 1/4. And to get rid of 1/4, you flip and multiply, so I'm actually multiplying both sides times 4. If that bothers you, you can subtract or divide by 0.25 and divide the other side by negative 0.25. But again, I think it's easier to take 4 times 5 and make it 20, add the 0, make it 200. But you can grab your calculator and you'll still end up with that being 200 and this being an x. So x is 200, but as answering our question asks, we want to know how much each alloy should use. So the 25% is x. We need the 50% also, so we need 1,000 minus x. So 1,000 minus x would be the same thing as 1,000 minus 200, and so that's going to be 800. So that's well and good. We've got our 200 and we've got our 800, but what is that? Well, those are grams of the different mixtures. So that's the first one is grams of 25%. So we have 200 grams of the 25%, and we have 800 grams of the 50%. And that is the total answer to the question being asked.